Good evening, one and all. So now we are going to discuss about the review of number system. So in the previous video, we saw that what is analog signals and what is digital signals, and now we are going to discuss about what are the basic number systems we are using in digital systems. So the review of number system is based on the majorly it is classified as an four major category. One is a binary number system. So that radix is a 2 and decimal number system that is a base of 10. Normally we are using only the decimal number system that is 1 to infinity, and octal number system and a hexadecimal number system. So this binary, octal, and hexadecimal number systems are used in operating systems and in all the digital devices for storing the variables, for storing the data in the memory. So in that cases, whatever the information we are storing in it, whether it may be the analog or digital signal, so that is converted into a basic number system that is binary. So again, that binary now the representation of variables in terms of a binary number system is a tedious process. So that's why we go for the representation purpose and all, we go for octal and hexadecimal number system. So base, what do you mean by base means it is a value which represents that particular number system, that is called base or radix. So already we know that the radix for the each and every number systems type. So it is used to find how many digits we can use it in that for the particular number system with the help of 0 to r minus 1. So what is 0 to r minus 1 means? If it is in case of binary number system, that is in radix of 2. So 2 minus 1 here is 1. So 0 and 1. Similarly, for decimal number system means that is r, here r value, that is in radix value is at 10. So here that is 0 to 9 it is represented. Similarly for octal number system. So the number system conversion is based on the 5 classifications: decimal to any other radix, or any radix to the decimal, and then octal to binary, vice versa. Similarly, hexadecimal to binary, vice versa, and octal to hexadecimal. So decimal to any other form. So if you are having decimal to any other form means, see to that if you have any decimal number like 1025. So in that case, if you want to convert this decimal number system 1025 as a binary, then we can do the consecutive division until you're receiving the we are receiving the remainder values of 1 or 0. Till that we are going to do that. And octal number system means we can, once we have a binary number system, that is a binary representation of a given decimal number, then we can grouping the binary numbers, grouping of binary numbers, three binary forms, then it will give the octal number system. Similarly, for hexadecimal means grouping of 4 bits of information, then it will gives you the hexadecimal number system. So here the dividend is the number which has to be converted, and divisor is a base value of a destination number system. So if you want to convert this decimal to octal, there isn't two method. Already I told you one method. If you have a binary system, then we can grouping of that 3 numbers, then it will give you the octal representation like that. Otherwise, if you have a decimal number, if you want to directly convert this decimal to the octal, then we can use this number. That is your continuous division. That is called the base value of an, that is divided by the 8, then it is said to be the octal, and divided by the 16, then it is said to be the hexadecimal number system. So now this is your one example. So see to that in that example, your number system is 24.25 value. So here the point before the digit we can use the division, but the but after that 24, here we have one point, so the 25 that can be point, After the digit, that is in terms of a digital, then we can go for the multiplication. So here point before the digit, we are using the division. So see to that here we are applying the continuous division. So until we are receiving 1, okay, or 0. So this is your binary representation of a decimal given decimal number. Then we go for that 0.25, how it will be converted into a binary. So see to that 0.25. So for that 0.25, we can do the top-down approach. So here 0.25 into 2. Okay. Then we are receiving zero point 0.5. We are taking only the whole numbers. So zero point 0.5, again 0.5 into 2. Then we are receiving 1. And again, we are taking only the decimal point here. So see to that 0 0.0 into 2. Again, we are receiving 0. So here the approximation we can do only for the 3 to 5 approximations is sufficient. So here within the third approximation itself we are receiving 0. So no need for the further simplification. So here we are using the top down approach, and while we are using the repeated division, here we are using the bottom up approach. So in that place only many of the students did the mistake. So that is an basic representation method. Actually based on this representations we are expecting the part A questions. And for the next class we are so based on this number system conversion only we can do the remaining parts of conversion, like how to convert the hexadecimal to binary, similarly binary to hexadecimal, like that. See to that. That is an one more example. So 24.25, same decimal number, how it will be represented in terms of an hexadecimal means. So it's a very simple. First we can divide this 24 by 16, then the remainder will be the 8. So we can, so again that 8, it cannot be divisible by the 16. So we can stop here itself. So that is your numerical whole number of 24 to the base 10. Your hexadecimal is 18. Next one is 0.25. How your 0.25 to the base value of a 10, the decimal number system that can be converted into a hexadecimal. Again here we can do the multiplication. So the C to that 0.25 into 16. So 4.0. Again we are taking only the 4, that is an whole number. Okay, so the remainder value here after the decimal, here we have a 0. So again, if you multiply the 0 with 16, you are receiving only 0. So now here we are using top down approach, and here we are using bottom up approach. So if you combined this outcomes, then we are receiving 24.25 decimal value is an hexadecimal representation of 18.4. Like that only we can do the remaining conversions and all. So next class we are going to discuss about what is an Boolean algebra, and how what are the simple basic laws we are associated with this Boolean algebra. Thank you.